In this video, we're going to do 3 geometry examples, and geometric applications lend themselves well to the concept of learning how to solve equations. So the first one that we're going to look at says one leg of a right triangle is 7 more than twice the length of the other. Alright, so anytime you have anything involving a geometric problem, if the diagram or picture of the shape is not provided, you should draw one. So let's insert one here. So once you've got your triangle drawn, or as I did here, bring in a picture, which obviously wouldn't be what you'd do there on paper, but we were told that one leg of the right triangle is 7 more than twice the length of the other. So let's call the shorter leg x, and then let's translate 7 more than twice the length of the other, which should sound familiar because that was actually example 1. So that is 2x plus 7. Actually, a variation of the very first one because that was less than. Alright, so we have our leg lengths labeled, and then we read on to see that we are to write the area of the triangle as a function of the shorter leg length. In other words, as a function of x. So we write the area formula from geometry, 1/2 the base times the height, and then we replace each part with its algebraic representation in this problem. And the base here is 2x plus 7, and the height is x. So now we've got base and height replaced in terms of x, and then we just multiply everything together. So in this case, we're going to basically be distributing the 1/2 and the x at the same time. So 1/2 x times 2x would be x squared, and 1/2 x times 7 would be 7/2 x. And that's the answer, with an ugly box around it. Then we go to example 7, and I gave you the diagram for this one, so I went ahead and put that in before I started the video. It says a circle is inscribed in a square, and then we are to write the area of the circle as a function of the side length of the square. So since it said the area of a circle, we're going to write area, and it might be helpful to do a little subscript, and as your subscript, draw the shape of what you're writing. And anytime you have 2 shapes involved in one problem, that's good practice. So we write the area of the square just in its generic form, and then we look at our diagram and see what we can do to label it with the information we were given. And our job is to write the area of the circle as a function of the side length of the square. So the side length of the square would be s, and obviously these would all be congruent, and that corresponds to, for the same, let me get my straight edge tool here, corresponds to the same thing if the circle is inscribed in the square as the diameter of the circle. So the diameter of the circle is equal to the side length of the square, which would imply that our radius is s over 2, because it would be half the diameter, which is equal to the side length of the square. So we then replace what we have, and again, we're going to be writing this in terms of s, because that's what we were told to do. And you could use x here just as easily. I'm just making it more emphatic that that's the side length we're working with. So pi obviously stays pi, but then now our r gets replaced with s squared. I'm sorry, s over 2, but that is squared. So then we rewrite this as pi times s squared over 4, and then for our final cleaned up answer box version, we would have a of s equals pi, oops, let's do it this way. Let's bring that 4 over here under the pi, because pi is a constant, so we can put all our constants together. So a of s equals pi over 4 s squared. And that's that one. We have one more geometric example. It's a little more involved. And we start with the information that, and I've only written part of it here, a right triangle is situated so that one vertex is at the origin, the vertex of the right angle is on the x-axis, and the third vertex is on the graph of y equals 10 minus x, 10 minus x squared. So A says draw the implied triangle on the graph and label its vertices. So again, I'll grab my straight edge tool. We'll go in and put one vertex at the origin and one down the way on the x-axis. Let me try that again because it didn't put it where I wanted it. Still not putting it where I want it. Maybe I'll get it this time. Nope. I give up. I'll use my pen. Alright, so I have one vertex here on the origin, one vertex somewhere on the x-axis, and then one vertex, and if that's where my right angle is, I have to go straight up to the function and put my third vertex there, so that the triangle would look something like this, sitting inside the parabola like that. Now it says to label the vertices, and I'm going to switch colors because that yellow is not showing up terribly well here. So let's go with this darker green, and then obviously the vertex is 0, 0. This point, this vertex would be x0. We have no way to know specifically what x it is right now. And then the coordinates of this point are also well, it has in common with the point on the x-axis x, and then the y-coordinate is 10 minus x squared. If you can label the points on a diagram like this on these kinds of problems, and you will see a few of these before the end of the semester, you come a long way towards being ready to do the rest of the problem. So then part B says write the area in terms of x of this triangle. So again, we start with our basic formula, A equals 1/2 BH. And that's not so much for you to know where it came from, but for anybody who's looking at your work to know the progression you went through to get to your answer step by step. So then we're going to have A of x equals, and then you just replace each part of the formula with the x notation from the problem. Alright, so the length of this side, since this vertex is x0, that means that this side length is x, because I am x away from the from the origin. So my base length is just x. And then when I go up, how far up do I go to get there is the y-coordinate. So that means my height is 10 minus x squared. And then again, as we did on the previous example, we have some distributing to do, and we, ironically enough, are also distributing 1/2 x in this problem. So 1/2 x times 10 would be 5x, and then 1/2 x times x squared would be minus 1/2 x cubed. And that is our area formula for the triangle as it was described, and the end of our geometry examples.